Yeah. There's another one, like I said. Okay, so hello Algebra 1 students. Today we're going to look at finding the equation of a line that does some simple stuff, so that meets simple criteria. The first two examples we're going to look at are just a line that goes through 2 points. So we need to make the equation of a line, y equals mx plus b, that goes through both of those. There's a few different ways to do this, so I'll show you 2 different methods. You can choose the one that you prefer. Okay? One of them we'll use mx plus b with. The other one I'm going to introduce a new version of mx plus b called point slope. If you like the new version better, you can use it, or you can just stick with the old version. It's up to you. So the first thing we need, if we're going to have our line pass through these 2 points, is we need to figure out what the slope is. In other words, we need to compute the average rate of change. You guys have been doing quite a bit of that and making some progress, I think. So what is the slope? Well, let's call it m, because that's what we've been calling it. So how do I find the average rate of change or the slope? I put the y's on top, or do I put the y's on the bottom? On top, right? So what are my y coordinates? It really doesn't matter which one you pick first, by the way. Usually I pick the second one first, right? I think that's been the way I've done it, but it doesn't matter. So the second y coordinate is which one?
It's 0.
-1 is the y coordinate. The first y coordinate in this problem is 3. So y's on top, x is on bottom. That's going to accomplish rise over run, which is slope. So what x matched -1? 0. What x matched 3? 6. And of course, when we do slope, we've got to think about the change. So that's going to be subtraction. All right. So now we've just got to simplify, and we'll have our slope. That's ingredient 1 for the 2 ingredients we'll need for our line. So -1 minus -3, that's like starting zeros here. Here's -1 going that way. So it's going to be -4. And then 0 minus 6 is just -6. I think we can simplify that one.
Yeah, it would be 2 over 3.
2 over 3 is correct. Negative over negative is a positive, of course, right? Okay, so what's the equation of a line again? We've known it for quite a while. You guys are fairly good at it now. Y equals? Good. So we have m. We just need to find b. So let's stick m in. We got that it was 2/3. So this line must be going up, right? We've got a positive slope. I need to find b. If we're going to create a line that goes through those 2 points, it's got to go through them both. We've already got the slope that will go from one to the other, so now we just need to use a starting place. That's really what b was to begin with. You can pick either point basically now and plug it in, and you'll be able to find b. So pick your favorite one, plug it in. I like 0 and -1 because those are nice simple numbers, 0 especially. So I'm going to put 0 in for the x or the y. It's the x, so it goes in for the x. And for y, I'm going to put -1. This is like an ingredient problem. You're sticking in one ingredient at a time. I don't know what b is yet. Now I'm going to solve for it. The nice thing about picking 0 in this problem is what's 0 times 2/3? It's gone. I'm going to say it goes to 0. So all that's left is -1 equals b. There's my second ingredient. My first ingredient was up here all along. So now all I need to do is put them together, and I have my line. That's the goal on every single one of these problems, come up with a line. So our line is y equals 2/3 x minus 1. Of course, we could graph that if we needed to. You guys are good at that. So you start at -1 and go up 2 over 3. So your line would look like this. If you'd like to graph all the problems just to get some more practice, you can. I don't think that's required though. Okay? There's one of them. If you're watching the video, you might pause and try this one now. In my class, we're just going to keep going. So, same kind of thing. 2 different points, make the line. First, find the slope. So I'm going to say m equals, find the slope. Y coordinates, x coordinates, the change between them. So the change between 9 and 1 is 8. Change between -2 and 0 is -2. -4. We could leave it as -4/1 because, of course, slopes are nice to write as a fraction, so you can see your rise and your run. It's up to you. I don't care. But that's it. We have ingredient 1. So we have m. We only need what now? We only need b. So I'm going to use the equation of the line. You could do this 2 different ways. I'll do it the other way with you guys. You know what? I'll have you guys use mx plus b to do this in a second. Let me show you the new way. Here's another one. You might like this better. This is another equation of the line. It's called point slope. Here he comes. Y minus y1 equals m times x minus x1. A lot of people think it's a little bit easier to solve for b when you do it this way. Let me show you why. So we've still got m in it, right? So I'm going to stick m and put it in. It's -4. Y is y. X is the variable x. Minuses are part of the formula. And x1, y1 is just designed to be a point that the line goes through. And I think that's what we're trying to do on these problems. We're trying to make it go through these points. Again, it doesn't matter which one you pick. The slope already kind of sticks them together. So which one? Let's pick -2,9 this time. That would be the easier one, but I'll just pick this one. Okay? So y1 is 9. x1 is -2. And I just need to simplify it until I have mx plus b. This is another option you guys have. So y minus 9 equals -4 minus minus is plus. And now I'm just trying to get y by itself. So I'm going to do some distributing right here. We'll be doing lots more of that as the year goes on, a whole bunch more in different ways. Get that. And then I want y by itself, so what needs to be moved? Can you guys tell me what's in the way of y? The 9. So if I want to move that -9, how do I move it? Added. Right, so it's being subtracted.
Yes.
You guys are going to be really good at solving equations when we get there. Watch how easy this part is before Christmas. We're going to have a nice, easy little unit before Christmas. It'll be easy if you've been paying attention to this other stuff. 9 minus 8. What's 9 minus 8? +1. So at this point, I'm going to pause. You should pause the video as well and see if you get the same line using the other technique. So instead of using this, start with what you've always been used to. Y equals mx plus b, and do it just like I did that one, and you should get the same answer. If you like the new thing better, fine. If you just like to stick with mx plus b, fine. I don't care. Either thing is just as good. So pause it and try it out. Okay, so my class checked this. We were going to use the other point in addition to the other method just to show that there's lots of ways to get the right answer. So in this case, we're still going to stick in -4 for the slope. We're going to stick in the other point instead. So the y-coordinate on the other point was 1, and the x-coordinate was 0. And b is not yet found. We're solving for it. This goes away. So that says 1 is b. So in this case, this is a lot faster way to do it. Sometimes this is a lot faster way. It just depends on what your numbers are. So it's good to know the both. But 1 is good enough for this year. So then we get y equals, our slope was -4. Put an x on your slope always, and b was 1. And you can see we get the exact same answer with the other point with the other method. And that one was shorter that time, so it just depends. All right, so let's find another type of condition that's pretty basic that we should be able to build a line out of. So the only other thing we're going to look at in this lesson is this symbol means make a line parallel to this old line that goes through this spot. We know how to make something go through a spot. We just need to talk about parallel. And then this one, what do you guys think this symbol means? Perpendicular. That's the symbol actually for perp. So this time we'll make a line perpendicular to that. We'll talk about that for a second. We'll make it go through a spot. Okay, so what do we know about parallel lines? Let me just draw some parallel lines up here. Anytime lines are parallel, like this one and this one, what do you know about them? They have like the same slope. So the only thing I'm going to use out of this is its slope, because my new line is going to have the same one. So what's the slope on that old line? 5. So my new line's slope is 5. That was even easier than what we just did. You don't have to do an average rate of change. You've just got to say, hey, look at the slope. Bam. That's the slope I need. I think we already know how to make it go through a point. You have two choices, mx plus b or the new thing. I'm going to do mx plus b in this one. So mx plus b, plug in your ingredients. We know the new line's also going to have a slope of 5. We need it to go through the point 4, 5. So the y-coordinate is going to be 5. The x-coordinate is going to be 4. We don't know what b is, we're going to solve for it. So that says b plus 20 equals 5. If I want b by itself, because I'm trying to find it, what's in the way? The 20. So how do I get rid of it? Subtract it. Very good. 5 minus 20 is negative, right? Negative 15. I would get in the habit of just circling it when you've got a final ingredient. So we've got that, and we can write our line down. If we wanted to graph it, it'd be just as easy. So the new line that's parallel, I'm going to call it y parallel. You don't have to, but that really clarifies the issue. So y parallel is 5x, because that was the slope, so I've got to stick an x on it, minus 15. We could graph it if we needed to. We'd start down there and go up 5 over 1. Okay? What about perpendicular? Perpendicular lines are those ones that meet with what kind of angle? I hear it.
Intersecting.
They intersect in a special way, though, just right. It's got to be just right. It's got to be 90 degrees. You got it. So it's got to be just like that. So one of the slopes is going to be like negative, and one of the slopes is going to be positive. So I think you start by working with the old slope. What's the old slope here again, guys? 3. You make it negative. That's one thing you have to do. But if you go 3 versus negative 3, I think you'll get lines that go like this. Okay? You need it to go a little bit more. You know what I'm saying? There's actually two things. I'd write that in your notes for sure. To get a perpendicular slope, one, negate. That means do the opposite. Positive is negative, negative is positive. Okay? And 2, reciprocate. What's reciprocate mean?
Switch the numbers upside down.
You do upside down, exactly. So reciprocate, a nicer word for that might be flip, you know what I mean? And negate, a nicer word might be like positive turns to negative and vice versa. Opposite. In fact, that's the way a lot of people say it, opposite reciprocal. Very good. I like it. So you guys are totally able to do this. Just gotta practice. That's all it takes, practice. So that means my new slope this time, I guess I used orange last time, so I'll stay consistent. My perpendicular slope, in fact, that's how you write it. The opposite of 3 is negative 3, but then I have to flip it. So it's going to be negative 1 over 3. And that's my first ingredient. Then I've just got to make it go through the point. We've been doing that a bunch of times now. So I'm just going to use mx plus b again. So I'll do it over here. So y equals mx plus b. I know my new perpendicular slope is going to be negative 1/3. What point did they want this one to go through? 3, 2. So what am I going to put for the y? 2. What am I going to put for the x? 3. And b is just chilling until we find it. So what happens here? 3 1/3? That's like 3 over 1, right? I think that just crosses right out. I gave you problems which all pretty much, maybe one of them works out with fractions. They all pretty much work out nice as we're just starting this out. Of course, in the future, gloves gonna come off. Right now, the gloves are on. So I think what's left there is negative 1 plus b. If I want b by itself, that negative 1 has to move. How are you gonna move it? Add it. So I get b equals 3. I've got my first ingredient, got my second ingredient, ready to make my perpendicular line. My perpendicular line, perpendicular to 3x minus 1, that goes through that spot is negative 1/3 x plus 3. If you don't believe it, let's put it in our calculator. So many codes. Real quick, let's graph these lines and see if they do what they're supposed to do. I'm just going to turn my plot off. You can follow me or just watch. So my first line, the original, was 3x minus 1. And we created one that was supposed to be perpendicular. Let's see if it is. I'm going to go alpha y equals negative 1/3 x plus 3. Zoom 6. So there's the first old line. Here's the new line. Could you guys believe or buy that those look like they're perpendicular? Looks like it's a little bit off from 90 degrees. I think that has to do with the window. If you pick a zoom square window, that makes it really nice and square. It'll look better, I think. Yeah, a little bit better that way. Yeah? Does it look like they go through the point 3,2? Does this guy go through the point 3,2? I'm not sure. I could check. I could say second calculate value 3, 8 for that one, but it's not that one that was supposed to go through 3,2. It was the new bold line. If you press down, you can see it sits right at 3,2. So it does both things. It satisfies being perpendicular and it satisfies going through the right spot. That's it. I'll see you next time.